Okay, guys, so these notes are over radicals. We've actually already talked about simplifying radicals and adding and subtracting radicals. Today we're going to focus on multiplying and dividing, but I'm still going to go over simplifying and adding and subtracting really quick. So we've already talked about what the radical symbol means. It's what number times itself gives you the number underneath the radical. So anytime that the number isn't written in the corner of the radical, it's always a square root. So like the square root of 9 is 3 because 3 times 3 gives us 9. Okay. So when we're simplifying, we look for perfect squares, and I gave y'all a list of perfect squares whenever we were still in school. So you can always reference back to that, or I can, at the end of this video, I can list all the perfect squares for you. So the square root of 25, we've talked about, is a perfect square. It is positive 5. Negative square root of 81, if there's a negative thrown in front, it's got to stay with it. So that would be negative 9. Now the square root of 50. 50 is not a perfect square. However, if we look at our list of perfect squares and we find a number that does go into 50, we could break that up and say it's the square root of 25 times the square root of 2. That's a multiplication right there. It's hard to do. Okay, and then the square root of 25 we know is 5, and then we don't know what the square root of 2 is, so we would leave it as radical 2. For negative square root of 300, 300 is not a perfect square, so we're going to look to see, is there a perfect square that goes into 300? So that would be 100 times 3, so we would say it's the negative square root of 100 times the square root of, that's really hard multiplication, times the square root of 3. The square root of 100 is 10, so it's negative 10, and we don't know what the square root of 3 is, so radical 3. Okay. Oop. So the square root of 32, again, we need to find a perfect square that goes into 32. So 16 times 2 is 32, so it's the square root of 16 times the square root of 2. And the square root of 16 is 4, and we don't know what the square root of 2 is, so we leave it as radical 2. The square root of 20, a perfect square that goes into 20 is 4. So we would break it up and say it's the square root of 4 times the square root of 5. And the square root of 4 is 2. And then we don't know what the square root of 5 is, so we'd leave it as radical 5. The square root of 75. So we would break that up and say it's the square root of 25 times the square root of 3. And the square root of 25 is 5, and we don't know what the square root of 3 is, so we'll leave it as radical 3. So again, we've done simplifying quite a bit this year. Now, adding and subtracting, we talked about this before spring break. You can only add and subtract radicals if the number underneath the radical, the radicand, is the same number. If it is, then you'll just add or subtract the numbers on the outside, and the radical tags along. So 6 radical 3 plus 2 radical 3, they're both the square root of 3, so we can add them together. So really we're just going to add the 6 and the 2 together to get 8 radical 3. Okay, next one, 5 radical 2 minus 8 radical 2. They're both the square root of 2, so we're going to combine the 5 and the negative 8 to give us negative 3 radical 2. Now, if the number underneath the radical isn't the same, then you need to simplify to see if you can get them to be the same. So 6 radical 11 plus 9 radical 44. Those are obviously not the same number underneath the radical, but we can simplify one or both of them. So 6 radical 11 I can't do anything with, but 9 radical 44, I can break up the square root of 44 and say it's 9 times the square root of 4 times the square root of 11. So really it's 9 times 2 times the square root of 11. So that's 18 radical 11. So that is what we're adding to 6 radical 11. So now that the number under the radical is the same, we'll combine the 6 and the 18 to give us 24 radical 11. All right, next up, the square root of 50 plus the square root of 18. So 50 and 18 are obviously not the same number, so we'll break it up and say the square root of 50 is the square root of 25 times the square root of 2, which is 5 radical 2. Plus the square root of 18 we'll say is the square root of 9 times the square root of 2, which is 3 radical 2. And now the number underneath the radical is the same, so we can combine 5 and 3 to get us 8 radical 2. Now we're into the new stuff, so multiplying. So for multiplying radicals, anything on the outside of the radical multiplies together, and then anything under the radical multiplies together. And then you just see if you can simplify at the end. So the square root of 7 times the square root of 3, I would multiply the 7 and the 3 to get square root of 21. And then I would check to see, are there any perfect squares that go into 21? There are not, so my final answer is just the square root of 21. Next up, the square root of 3 times the square root of 15. So I would multiply 3 and 15, so I'd get the square root of 45. Ooh, that's an ugly 5, sorry. Square root of 45. Well, then I'm going to see, are there any perfect squares that go into 45? There are. 9 times 5. So I would break it up and say it's the square root of 9 times the square root of 5, which is 3 radical 5. All right, next one, 2 radical 6 times 5 radical 2. These have numbers on the outsides of the radical, so those will be multiplied. So 2 times 5 gives me 10. And then the square root of 6 times the square root of 2 is the square root of 12. So I have 10 radical 12. Well, now I need to look and see, are there any perfect squares that go into 12? So 4 times 3. So 10 times the square root of 4 times the square root of 3. So 10 times 2 times the square root of 3, which is 20 radical 3. The last part is dividing. So it's also called rationalizing the denominator. So you can never leave a radical underneath the numerator. You can't leave a radical in the denominator. So to get rid of it, you're going to multiply top and bottom by the denominator's radical. So 5 over the square root of 3, I would multiply top and bottom by radical 3. So that would give me 5 radical 3 over the square root of 9. And we already know the square root of 9 is 3. So my final answer is 5 radical 3 all over 3. The next one, the square root of 8 over the square root of 5. So I'm going to multiply top and bottom by the square root of 5. So I get the square root of 40 over the square root of 25. The square root of 40 actually simplifies further. So I can break up the square root of 40 and say it's the square root of 4 times the square root of 10 over, we already know the square root of 25 is 5. And then the square root of 4 is actually 2. And then we have our radical 10 all over 5. The next one, 2 radical 4 over 8 radical 3. I want to simplify this before I just start trying to rationalize the denominator. First off, if I just look at the numbers outside of the radical, I have a 2 over 8. 2 over 8 I can simplify each by 2 and make it 1 and 4. So I really have 1 times the square root of 4 over 4 radical 3. Well, also the square root of 4 is a perfect square. The square root of 4 is 2. So really I have 2 over 4 radical 3. We can simplify again, looking at the numbers outside of the radical. 2 over 4, I can reduce by 2 and make it 1 and 2. So I have 1 over 2 times the square root of 3. So then now from here, I'm going to multiply top and bottom by radical 3. I'm running out of space, sorry. So I get 1 radical 3 over 2 radical 9, which is really the square root of 3 over 2 times 3, which is the square root of 3, oh, I'm out of space, over 6. Oh my gosh. Sorry guys, I ran out of space. But we get radical 3 over 6. That one could be approached a ton of different ways. You could just go straight into simplifying and multiplying top and bottom by radical 3. From there, you would have to simplify at the end. It really depends on how you want to approach it. But that's what I do, is I will simplify first, and then I multiply by the radical in the denominator. And that is it for our operations of radicals notes. Oh, wait, I'm going to go back. I'm going to list perfect squares here for you. So our perfect squares we've been working with, we start off with 2 times 2, so 4. 3 times 3, so 9. 4 times 4, so 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9, which is 81. 10 times 10, which is 100. 11 times 11, which is 121. 12 times 12, which is 144. 13 times 13, which is 169. 14 times 14, which I can't remember off the top of my head. 196. 15 times 15 is 225, and we should be good with just those numbers. But if you needed to continue on, you would do 16 times 16, and then 17 times 17, 18 times 18. So those are our perfect squares we're working with. All right, that's it for our radicals.